I gave that talk already a couple of times in different conferences, and I decided to change the name. The name before was Fun.CQRS, a Scala library built on top of Akka to build CQRS applications. But I learned that if you choose a title with more buzzwords, they give you the main room. So I changed it to Functional and Reactive Event Sourced Applications, and everybody comes to the talk, and they often give you the main room. Last time I also got the main room, all the conference was in the room, but it was a single-track conference. Anyway, so a little bit about myself. So my name is Renato Cavalcanti. So I have a company, I live in Belgium, and I run the Belgian Scala user group. And I have a company called Strong Typed, where we give consultancy and training on Scala. Despite my name, I'm not Italian. It also happens that after my talk, there's always an Italian guy coming to talk with me in Italian. And since I know the code motion, there's lots of Italian here. You guys just please come talk with me, but not in Italian. I do understand, but I can't speak. Maybe you got a hint which nationality I have later, or you can recognize from my accent, I don't know. Okay, so the agenda, I have only 40 minutes today, so I will try to compress things a lot. So just to have an idea, who knows what is CQRS? Okay, that's great. Event sourcing. Okay, if you know CQRS, you are supposed to know what is event sourcing. Who knows what is Akka? Oh, that's just great. Because, well, Fun.CQRS is a library that I wrote that is built on top of Akka, but not necessarily, you can use other backends. For the moment, I have a memory backend, but Akka backend as well. We'll focus today on the Akka backend. So, CQRS, it's about, I don't like the name because it's very hard to pronounce, and with my accent, people understand something else. They understand secure your, I'm not allowed to say because of the code of conduct. But once I had a guy, you talk about how to secure your in Scala. Well, that's more or less that. So the idea of CQRS is to have two models, the command model and the query model. So CQRS stands for command query responsibility segregation, so we split them. And the command model is there to get commands. And we also call it the write model, and it will produce events. And events are persisted. And from those events, you can generate views. But the view model, or the read model, they may be totally different. The read model can contain data that you go fetch somewhere else, can contain data that you calculate later from the events that you have. So the command side of the write side should only contain the information to validate the commands and produce events that are meaningful. The thing is, why would you do that? Because we all run against deadlines, and now we have to build two models and maintain them. Well, the main goal of doing that, there are many aspects. But one of the main reasons is that when you have the write sides, you just store your events in append-only fashion, which is very efficient. So you can have a server that's accepting the commands, validate it against your write model, and flushing events to the storage without doing query. And that increases your throughput on the write side. On the read side, you can take your time to produce data that will be displayed to the user, to generate reports, to use in your Spark server if you want to do analysis, and so on. By the way, who is familiar with Scala? Okay, who heard about it? Okay, wow, that's great. It's getting popular, more and more popular, I think. That's a good sign. So, the command side. First, we'll have a look on the command side, how it looks like. So we have this write model that will be on your system, and you send a command to it. and your write model has to validate it, okay? And it will emit one or many events. That's the result of sending a command to your model. If the command is not right, for instance, you say, if you have a shopping basket, for instance, and you say ship of order, but it's already ordered, so it's an invalid command because your shop cart was already bought, so you cannot buy it twice. That's an example that at one moment the command can be valid, but if you send it again, it's not valid anymore because you transition to another state that makes that command is not valid anymore. So once your write model emits events, what we'll do is we'll store those events in a journal-like storage. In Akka, you have a model called Akka Persistence, and you have different plugins for Cassandra, for Postgres, for JDBC database, for Mongo, and so on. And actually, you choose the one you want to use, and but your code is more or less agnostic of the storage that you're using. You still have to configure it, but you don't have to deal with the storage. Once the events are stored, then you apply it to your write model. Only after it is stored. And the reason for that is that, well, you could apply the events directly to your model, but you also want to have an entry point on your model that accepts events, because as we'll see, there is a situation where you replay the events. So you need a method on this write model that can get events and reconstruct the write model. So I will be very brief about Akka, because I think people here know what is an actor system, but how it works. So in the previous slides, I was talking about actually the main principles of event sourcing. I'm not talking about Akka here. That's just how event sourcing should work. It turns out that Akka is very similar to event sourcing. Well, it's very similar to the idea of sending messages of commands to some entity. And so an actor system, so Akka is an actor system implementation for Scala, for those that are not familiar with Akka. So an actor system is an abstraction for asynchronous programming. If you are on the JVM, you know that if you want to run something on another thread, you have to start to have a callable of a runnable, and you send it to an executor service, or you start yourself your thread, which is a bad idea. And Akka will shield that for you. And it works with an actor that you code, and you don't initialize it. You ask the actor system to initialize it, and what you get is a reference to it. And you cannot touch the actor itself. It will live inside the actor, but you have something that we call an actor ref that we can send a message to him. Once you send a message, it's put on a mailbox, and on another thread, that message will be delivered to the actor, and it will do some work. It may send you back something if you ask for. There is two methods. You can tell, you send a message, or you ask. And if you ask something, you get a feature that will be completed sometime in the future when the actor answers your question when you ask something. But the main idea is, well, when I send a message, it's put on the actor system, actor mailbox, and then I can go do something else. My thread is free to continue my processing. And the actor will do it, will pick the message at some point. Why is that important that's very similar to the idea of CQRS and event sourcing. And because it's not about calling one specific method, but it's more the idea of sending commands. So different than when you have a classical object, you put methods and you mutate that object. Well, with an actor, what you do is send a message to it, and it will process that message at a later time. The Akka persistence plugin was initially called Event Sourced. Was an external third-party library that was integrated in Akka. And Martin Krasser, that was the guy that created the Event Sourced project, he had that insight that, okay, if that's how an actor system works, what I miss here is something that once I send commands to it, it can persist events. And if I have such a thing, and I can make sure that it will work inside the actor system, and I don't have to deal much with that, then I have what I need to do event sourcing. So that's pretty much what Akka persistence is. You send a command to your actor, it will do something, and then it will get the chance to persist. And while he's busy with persisting that event or whatever you want to persist, it will not process any other message. An actor is like that. It picks a message from a mailbox. You can send other message, but it will go to its mailbox. It will only pick the next message when it's finished. So an actor is guaranteed to run in one single thread. So you cannot have the same actor processing two different messages. So the insight is that Akka, it's a very suitable middleware for event sourcing. There is this plugin, the Akka persistence, that is pretty much what we need. And then, well, there are many projects doing what I'm doing, actually, building libraries on top of Akka to do event source. Well, there is the plugin, but when we started, I work for the Flemish government in Belgium. And when we started using event sourcing, we said, okay, we are here coding inside the actor. It's too complex. We should have a better abstraction that we can code totally outside the actor and say, okay, that's my domain, those are my events and my commands and my events, and now when I want, I give it to be run inside an actor. That's how that was our idea at the time. There are other implementations that where you have to extend an actor yourself and start to code everything inside. But it's very repetitive because the operations of CQRS are very well defined. You send a command, it produces events, the event has to be persistent, and that's it. So, what else? For the moment, we are only focused on the right model, okay? The right model, the idea, okay, you have this actor in memory, but if it dies, you lose the state. If you send a new command to it, the actor system will initialize it, and you take a look on the event store and say, okay, give me all the events that were ever applied to him, that were ever persisted, and I reapply it again, and bring that actor to the last known state before I accept the next command. That's the principle, because you validate the command against the current state of your right model aggregate, if you use a DDD terminology. And so you replay. But of course, if I have an aggregate or right model with many, many, many events, and every time that, if it's not in memory, I send a message to him, I have to replay that all. Of course, that's not efficient. And there is another part of the Akka persistence model, which is snapshots. So the snapshots are discardable, but they help you, well, for instance, you can configure every 100 events, you save a snapshot. So if I have to reinstantiate again, I load the snapshot and the events that happened after that snapshot. So I don't have to replay 1,000 events. So we use snapshots, but it happens very often when we have a new release. That first thing that we do, we take the events that we got up to now in production. We take only the events. And we take that dump only with the events, and we start the system on our machines to see how it will behave. And what happens? And we instantiate the aggregates. And what happens is that all the events from day one will flow through the aggregate. And by doing that, we can verify that the system is still robust. And that's one of the advantages of having event sourcing. And so very often we drop our snapshots and we let them be regenerated. Okay, so some code. I had an Akka demo, but since I have the impression that you guys know more or less what is Akka, I will not do the demo. I only do the demo of event sourcing. So my example here, yeah, this. Okay, let's do lottery. Okay. I have a very simple domain. Okay, I'm talking for 50 minutes. I think I can talk slowly now. I have a very simple domain. It's a lottery. I give a name to it. It has participants. It may have a winner at some point in time. So I have a list of participants. It's very dumb, yeah? The participants is just a string. And I may have a winner or not, and I have an ID. And then I have here methods to add participants and so on. In Scala, what we do, we work very often with case classes, which are immutable. So if I want to mutate it, what I do a clone of it. So that's what is happening here. When I add a participant, I'm actually mutating that lottery object by saying, taking the old participants, add a new name, and assign to the participant list of my clone. So that's just simple code. And then comes more interesting part is, well, when you do DDD, we talk very often about the ubiquitous language. My idea is that when you mix that with event source and CQRS, your ubiquitous language is mainly expressed in terms of commands and events. The commands and events, they express what is possible in your domain. What are the operations? There is a second part of that, which is the behavior that we'll see in a while. But for instance, a lottery, what we have? First command is a create a lottery, and then add participant, remove participant. I can remove all participants in one shot, and I can run the lottery. These are the commands, and my events are lottery created, participant added, removed, and winner selected. Those are basically my operations. But now what I need is I need to have something to express how and when those commands are valid or not, and when a command will produce those events or not. So the second building block of that is what we call a behavior. And a behavior here, what we see is in Scala is a partial function. I have this case like a switch statement in Java. I'm just selecting, matching the state that I want and deciding which behavior I need to use for that state. So for instance, when it's uninitialized, it's very easy, I have to create it. So I created this write model, but I never sent him a command. So the first command that I will send is create lottery. So it's like a seed. So when it's uninitialized, I have here the create lottery. And basically, I have two actions there that I define here. The first is the handle command. I say, you handle that command. That's what you have to do. And that when you have this state of uninitialized state, let's say. So it's strange to say uninitialized state because exactly what it doesn't have is a state. Anyway, so you have a command handler that goes from a command and produce an event, lottery created. And you have an event handler that from an event calls the constructor of a lottery. That's a special case because that's the one that I need when I don't have yet my object. So it's like a constructor, validation and constructor. Okay? Then the next is, well, when you do pattern matching in Scala, you have this guard clause. What I do here is saying, okay, if it's initialized and it has a winner, so I will reject any kind of commands because I'm done. The lottery was run and I'm done. I cannot run that lottery again. I cannot remove participants. I cannot add participants. So the reject command, it's again an action, but this time it is defined inside the lottery. Because now I have already a lottery, so I can define it here inside the lottery class. And basically I say, for any command, if I have a winner, I just give back an exception. I'm not throwing the exception, I'm just using exception as a type to signalize that it's a fault condition. I'm not throwing that. And that's, in Scala, we usually don't throw exceptions in functional programming in general. So what we were looking for when we were doing that is a way to have an API that is expressive enough that could, where we could concentrate on our domain modeling. The commands, the events, the behavior. We don't want to deal with Akka. When I'm coding my business domain, I don't want to deal with complexity of Akka. And by the way, inside Akka is always the same for this kind of use case, for CQRS event sourcing. So I code it once, but everything that is specific, I put it outside. So that's what the main idea. So we saw when it has a winner, I reject everything. When it has no participants, the only thing that I can do is I can accept participants and I cannot run without participants. So you see I have here actually two actions that I merge them, I fusion the actions, so I have one bigger action that is the composition of those two. And here again, I cannot run without participants is basically saying I will reject any run command if I have no participants. Just the business rules of a lottery, okay? And the last one is, okay, I can reject double booking. If the participant is already added, I will not let him be added again. I can accept a new participant, I can remove participants, and I can run the lottery. And these are all these kind of actions that are all combinations of command handlers and event handlers, okay? So that's pretty much the right side of your application. So let's see how it looks like in a demo. Yeah, the other thing is, once I have this lottery and the behavior, the commands and the events, I have to declare it to my library, to my Akka backend, and say, okay, this guy is an aggregate, is a right model, and I want to use it as an aggregate, and I want to send commands to it. And what you see here, if you know Akka, you find it very similar. Well, basically what I'm doing here, I'm configuring an aggregate of type lottery and giving the behavior to it. This will create for me an actor behind. Well, what will happen is I will have an aggregate manager for lottery. And depending on the commands that you send, it will initialize an actor for it or not. But that's more detail. For today, we don't need to go that much in detail. Here, I have something very similar to an actor ref, but it's an aggregate ref. It's different because it will work like an actor, but it's typed on the commands and the events. I don't know if you know, but Akka is untyped. So once you have an actor ref, you can send whatever to it, and if it's not configured to answer to the message you send, we'll just ignore it, which can give you some nasty bugs. So what I'm doing here, I will create a lottery. I have a fixed ID that is defined here, code motion. Can you guys read? Huh? And then I create a lottery, I send a command, I send participants, boom, 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 4 guys that I picked those names randomly on internet, and I run it, okay? The Akka demo, okay. But what I want to show is that for the moment we'll that main class here only has the write model. So what I will do, I will send a message to that aggregate. It will process it. It will persist it. But I will not generate any view. It will go to the storage, and that's it. Just to show how they are, the write and the read model, they are totally unrelated. I'm running here, and hopefully it worked when I was on the train coming to here, so it should work now. That's it. You don't see it, because I don't have a view. I just send everything. And to prove that something is happening, I will comment out the create command, the participants, and I will run that lottery again. And let's see what happens. It says, I cannot run it because I have already a winner, and it's Paul. We know now the winner. Spoiler. You were supposed to see that when I do the view side, but now I put it on the error message. Okay, good. Paul, you got the prize. Is there a Paul here? Yeah? I need your ID card. Okay, so that was the write model. As simple as that. And the most important thing, to my opinion, is that it's possible to code your domain without thinking about your persistence, thinking about your middleware. You're just concentrating on your commands and your behavior. That's what you're looking for when we started, and we are pretty happy with the results. Well, this behavior API, it changed a lot. We tried different things. Is Don here in the room? Yeah. Hi, Don. Don is my first open source committer, and he was author of one of the APIs for the behavior that I changed later. Sorry for that, Don. Well, it was a time that we were experimenting many different things, and I think we had my colleagues were always complaining, yeah, you have a new API now? Every 2 weeks I came with something different. But now I think we are all very happy with that, I hope. And so that was the write model. And we have it now persisted. So the query side. The query side is when you query your persistence and let it flow, all the data flow to a view, for instance. I think I have 30 minutes, so 5 minutes for questions, so I will go very fast. Who was in the sketchnoting talk? Yeah, when Linda was talking about your kindergarten skills, that's what happens when you try to draw a projector. So I tried to do sketchnoting as well, but my skills are not yet there. So what are projections? Projections, we use that to project what we see in the events. We use projections to build views, but not necessarily. You can also use that for other things, but what I will show today, it's only for views. And you basically do a query, say, okay, give me all the events of that type for this kind of aggregate, and let it flow to me, and I will generate view models from that. Well, that's what I was explaining. We have here the event store, all the events, and I will just query and let them flow. And the view, main view, I split it. So basically, I need some infrastructure to say I need a projection of I want all events for the kind of that are tagged as a lottery. This is the internal of Fun.CQRS. Here is my projection. I will show you in a while how it looks inside. And I'm just saying, okay, in the same way that I configure my aggregate, I'm configuring my projection. I'm just saying to Akka, do that for me, and start to query and send the events to that lottery view projection. Well, there inside, well, I just get lottery, and if I get a lottery, I create a lottery view. If I get an event of type update, well, I go to this update function here. that will have all these options, participant added, winner select, and so on and so on. And the lottery, no, main view. And this lottery view is getting a repository. So for each event that comes in, it will generate a lottery view and it will add to the repository. In that demo here, I'm using in-memory repositories, so I'm not persisting the pointer. So actually, when you have a projection, what you have to do is, projections does not have a snapshot. You only have the last state, known state. So what you have to do, you have to save, you have to know which are the pointer of the last event that you process it. So when you restart the system, say, okay, my view is on that version, I can continue. And then I can continue from that point. I'm not doing that here because it's all in memory. So every time that I run that application, it reads all the events. And basically, I sleep here for, I let my main thread sleep for 2 seconds just to give it enough time so all the events flow to the view. And once I'm finished, I can ask for the lottery view. And well, my repo here gives me back a feature. It's not needed, but I didn't have the time to change that yet. So I always forget to change it, actually. And basically, I will wait till the result is there, but it's almost instantaneous. So let's run it. Voila. So what happens? We don't see it, but behind the scenes, it started. It asked to get all the events from 0, and it starts to send the events to the view. And that's pretty much everything about CQRS and event sourcing. And the thing is, I have explained it many times, and even in our team, when we started, it's amazing. Now, for me, it's very simple, but it's amazing how people get it wrong. And in the time, our team was also getting confused about those things. And after also giving this talk in many conferences, people come to talk with me, and then they talk about persisting commands and saving view snapshots. That's not that. We persist events. We have snapshots for the right model, and the views are not snapshots. And they are totally apart from each other. But the main important thing is even not the CQRS part, is about event sourcing. Event sourcing is the killer feature here. It's not CQRS. You can even have event sourcing having only one model. You don't need to have 2 models. So the main message is we should not build applications that are destructive. If you have a classic Java application, you have a multiple object setters and getters with Hibernate, and you only know the last state. You never know how was the state before. And what happens when you don't throw your data away? You get a full disk. Well, actually what you get is big data. You collect the data that you can analyze later. And if you have a destructive application, you're losing value. So the main idea, focus on events. They are the single source of truth, and nothing else matters. And credit goes to Metallica. And thank you very much. We have 5 minutes or so for questions. The code of Fun.CQRS you can find in GitHub, and the documentation partially completed. No, partially incompleted, it's better. You can find it at fun.cqrs.io. Questions? Yeah? I'm supposed to throw that to, it's not because I don't want to answer questions, but you have to catch it. Who's the guy? I will throw anyway. It's a mic. You have to take it and No, I think it's because of the recording. Let's try, otherwise I will...
1, 2, 1, 2? Okay.
Yeah, that's perfect.
So, I would like to argue about the snapshots.
Yeah.
Because the snapshotting is practically a fix to a problem that you create when you design the aggregates too large. So in other words, if you cleverly design the aggregate small enough, you never have to use any snapshotting at all.
Well, you have to, because at some point the aggregates will not be in memory anymore. If you restart the system, well, an actor, when he starts it, it stays in memory. And we have some functionality that we call a passivation strategy that will do kind of garbage collection. After some time or after more than 20, it starts to kill them. So if they go, you don't have the state anymore. The state of your aggregate is in your events. So once you bring it again back to memory, you have to replay the events.
Yes.
That may be fine for a lottery, because you have, well, to be honest, most of your aggregates, they have a very short life. And they have a couple of events. Think about a shopping cart. You start it, you add a product, you change your mind, you remove it, you put another one, you stay there for 3 days, you get a discount from Amazon because you're not buying, and then you apply it, and then you buy it. And then it's done. You don't have thousands of events.
Yeah, usually it's about top 10 or 20 events that you might have in an aggregate. So you don't really need the snapshotting in that case. You can replay 10 events or 20 in memory.
I have an aggregate that has 300,000 events.
Then something wrong is with the aggregate, I would say.
No, it's not. It's something that gets lots of writes. Lots of commands are sent to him. And it will never die. It stays there. It's not something that gets a final command like a run in a lottery of a buy shopping cart. It's something that will stay there.
I'm not really sure about that, because practically you can say that your application is an aggregate. So it will always stay there forever, and it has millions of events. But you don't make an aggregate of the application, right?
No, you don't make an aggregate of your application.
Yes.
No. But yeah, you need to know the use case to argue about that. But I think in our situation, it's pretty much correct what we are doing. And in those situations, you should use snapshotting. Otherwise, if you put the threshold for snapshot like 200, you probably never get one. But if you need to replay 200 events, well, a snapshot can be good. Why not?
All right, thank you.
You're welcome.
So,
any question? Here, now you have to throw it.
Throw it for me, please.
Where?
Yeah. Wow.
Nice.
Yeah. Good.
Hi there.
Yeah.
So I was wondering how you handle dependencies between read models from a consistency perspective. Like,
okay, how you handle dependencies between read models? You mean if I have two read models that are if I have a read model that has data from two different aggregates, or
no, if you have one read model which has data from two different other read models, like you want to build on them.
Well, I don't know if I understand your question, but we have a situation where we have different aggregates to build one view model. And what we do, we make a projection that will listen to all events, not from only one type of aggregate, but all the types that we are interested. And we do get them in order. So here in that view, I'm only processing events from lottery, but in my case, we have 3 different aggregates that I'm interested in their events, and I let it flow to my view model. Is that an answer for your question?
So, well, no, not really.
Okay.
I'm trying to ascertain how you handle consistency. With CQRS, you normally do it with a version per aggregate. Basically, the number of events on that aggregate.
Yeah.
But when you have a read model, suddenly it's sourced from many different versions.
Yes.
And then you need to somehow contain those versions, like in a vector or something, or you need a way of dealing with the consistency and variance of your system.
Yeah.
How do you do that in a manner where you don't have to do it manually all the time?
Yeah. From the aggregate perspective, on the aggregate side is strictly consistent, and it has an ID, and it will always be consistent. From the view side, there are 2 ways. Well, you have event consistency. Once you have, there is a delay between an aggregate and the production of your view. It's not done on the same transaction.
But you want strong consistency.
Well, if you want strong consistency on both sides, so you probably don't want to use CQRS, because the idea is to split them. So if you need strong consistency, you have two options.
As in eventual strong consistency.
Yeah. So eventual strong consistency, what do you mean? What I understand by that is it will be consistent when it finishes to read the string.
That you may need specific orderings between the aggregates. So otherwise you might have arbitrary interleavings.
The order is guaranteed. The order in your projections is the order that the events will persisted. That is guaranteed by Akka persistence. Now, if you have a view that gets events from two different aggregates, well, the problem is if you have inter-aggregate communication. If you have an event that is produced by aggregate A that may impact aggregate B, and well, if that happens, the events that will be produced by aggregate B will come after the events from aggregate A. So they will get in the storage, they will get in the order. The event store is one event store for everybody. It's not different tables per aggregate. So it's one. At the beginning, when I saw that, I thought, wow, that's crap. I want to have one event store per aggregate type. But then I realized later that it's wrong. What we want is actually a storage with all the events of my system in order. So if you have a view that depends on two aggregates, it will get the events in the order the events happen. Does it answer your question?
Thank you.
Otherwise, we can try to brainstorm later, because I don't know if it's fully answered. No. Questions? You have a question? Okay, thank you very much. If you want to... Don't hesitate to ask me questions in the hall. I can also show more stuff. Thanks.